Hello everyone, today I'll talk about the solution to the problem check if array pairs are divisible by k. Since this is a divisibility problem, it's common to think about divisibility in terms of remainders from division, in terms of the modulo operator, which is typically this percent sign. Because that gives us the value from 0 up to the, in this case k, up to the modulus not included in the modulus, and this is essentially the value that we would get if we were to add or subtract k as many times as necessary to fall in this half-open interval. And it's useful to think about remainders, and we're even given a tool in terms of this modulo operator in most programming languages. For divisibility, of course, divisibility means that the remainder is equal to 0. But we also know that whenever we add two numbers and later modulo them with this k, it's as if we were to first add their remainders. So we can essentially, for instance, a plus b and everything modulo k is the same thing as a modulo k plus b modulo k, again modulo k. So we can think of numbers as being exactly the same as the remainders, assuming that everything happens modulo k. Okay, so how can we use this in our problem? Well, if we have some numbers in our array, and let's say that we have a number here, some a, then what numbers can we use to make a pair with that number? Well, maybe this number is okay, and this number is okay, and this number is okay, and all the others are not okay. So what can we say about those numbers? Because they can be different. But if that sum is divisible by k, in particular that means that the sum of their remainders is divisible by k. So if we have some remainder here, then this thing would have to have the remainder equal to k minus this. Assuming that this is, let's say, k is equal to a, because there are some edge cases. So that means that pairing up the numbers, we only care about the remainders, and that means that, for instance, if we are taking modulo 5, and something has remainder 1, then we can pair it up with anything with the remainder equal to 4. 2 with 3, and we're happy. And now there's a single edge case, which is that if something is divisible by 5, we also have to pair it up with something divisible by 5 for the sum to be divisible by 5. So 0 matches with itself, so the number of zeros must be even. And likewise, if for instance our k is equal to 4, then 1 matches with 3, 0 matches with itself, but also 2 matches with itself again. So if something is divisible, has the remainder equal to 2, it has to match with itself. So again, for an even number, we have to check if half that number occurs an even number of times. For every number, we have to check if 0 occurs an even number of times. And for all the other possible values for remainders, we have to pair them up in this way and see if those are exactly appearing an equal number of times. So we take every value in our array, take it modulo k, and create a counter out of it with the counter constructor. And the main idea, of course, would be to match the remainder with what is necessary to get a sum that is divisible by k. So for instance, v modulo k should match with k minus v modulo k. This formulation also works for 0, because if v modulo k is 0, then k minus v modulo k is also 0. Those two edge cases is, of course, the count of 0, so the count of divisible values should be even, as well as the count for the two values that are half, whose remainder is half of our modulus, should also be even. So if they're odd, which we can check by, for instance, ending with the value 1, and of course this we only care about even numbers, so the number should not be odd, but this value, if it is odd, we have to return false. Of course, those checks always should return false if at any point a pair like this doesn't match. Otherwise we return true. And the final concept, the final detail maybe, is what to iterate over here, because we have, I think, 3 simple options. One would be to iterate through all the counts in our counter. That's probably the best in this case, but it's not what I'm doing. Another would be to iterate over all the possible remainders. But if k were to be pretty big, for instance, if k was up to 10 to the 9th, then there are too many remainders. But there is also a trick that's useful in some problems. It's not very useful here, but it's still showcased. That we can go through all the values in the array again. And in that case, we'll visit every possible remainder, because we look at the remainder of every value in our array. So that's why I'm iterating over the array. There are, as I mentioned, other options here. And this is the whole solution.